Okay, this is Module 11, and it really builds off of Module 10, which was looking at Boolean expressions. So in the last module, we saw that we were using a new data type, Boolean, and we were storing the result of relational operators, something like 5 less than 6, as a true or false value in a variable. It turns out that while we will create Boolean variables from time to time, most programs use Boolean expressions in conditional execution. That's where they're most commonly found. So that's what we're looking at in this section. So this topic is covered in section 3.3. We'll be looking at the basic conditional execution statement, which is the if statement. And so a while back when we started thinking about the anatomy of a C++ program for the first time, we saw the main function. And we saw that main function as being a grouping of code. And we had these curly braces, or these braces that were delineating the start and end of the main function. So far we haven't really had any other groupings, and now we start to see some more. So within main, we might have a section of code, or a grouping of code, delineated again by these curly braces, a group of statements that only execute if a given Boolean expression evaluates to true. All right, so it looks a lot like a function, but it's really just a statement. It's saying if this Boolean expression equals true, execute these statements, otherwise continue on forward. If you look at what the textbook talks about in terms of the real syntax of C++, these braces are in fact optional for if statements. If you leave the braces out, however, only statement 1, only the very first statement right underneath the if statement is connected to it. And the other statements, so if you had a statement 2, would execute either way. So I like to, especially when you're starting out C++, I would recommend that you save yourself a little bit of ambiguity. Ambiguity usually, and options usually end up in an increased number of bugs in your code. I would keep things simple and always use the braces and not really think of them as optional until you get very used to how they work. So the easiest way to take a look at and get a feel for how these if statements work is through an example. And I'd like to write a program, a very short program, that asks the user for 2 positive integers. And if they're equal, I'll have the program say yes, they're equal. And if they're not equal, I'll say which one is larger. So clearly when we type in 2 numbers, only one of 3 different options are going to print out. Either it's going to say they're equal, or it's going to say the first one's larger or the second one's larger. And that's kind of the nature of conditional execution. You get to pick and choose what statements actually execute. All right, so I've started the basics of the program. I've created 2 integers, x and y. I've read them in from the user, all on one line. And now I'm going to write my if statements. So the first condition is to see whether they're equal or not. And what we can do is we can just say if x double equals y. Remember that double equal sign. We're going to talk about this a little bit in a second. That double equal sign is one of the most common sources of error for anyone, not just people that are starting out. It's very easy to just write a single equal sign and not realize what you've done. The double equal sign does a comparison. This is an assignment operator. We want to avoid that because we don't want x to be assigned the same value as y. We simply want to compare the 2. So x equals y, x double equals y is a Boolean expression. If that evaluates to true, I'm going to say the values are equal. And we can build and just test that very first part. If I type in 4 and 5, you'll notice the only thing that prints out is this all done message that happens at the very end. So when I typed in 4 and 5, x was not equal to y. This Boolean expression was false. This if statement was skipped, or more appropriately, these statements within the if statement were skipped, and we just go down to the bottom and we print out all done. If we run the same program now with 4 and 4, we can see the values are equal, and then of course all done as well. So the if statement just gives you a kind of a side branch here, where this particular statement will execute if that x and y are equal. All done will always print out because it's not inside the if statement. And we can add more. To that if statement, of course. I don't know what we should print out, but just for demonstration, we'll just print that line too. And each one of those are attached to the if statement. So if I type in 4 and 5 again, you see neither of those statements come in, and 4 and 4, and we see both C++ statements print out. All right, so the next part is, well, if they're not equal, which one's bigger? And we really can construct that as two statements. We can say if x is greater than y, see out, first value is larger. We don't really want to print out x is larger because we didn't talk about x in our prompt. The user really won't understand what we're talking about. And then we'll check the other side. If x is less than y, see out, second number was larger. So 3 independent if statements, and I'll get rid of this line 2 right now. Because of the way we arrange this, x is going to be either equal or one of them is going to be larger. So there's really no way for multiple statements to exit, multiple print statements of these 3 to come out into our screen. If we type in 4 and 5, it'll come back and say second number was larger. So in that case, 4 and 5, this would be false, we skip it. 4 and 5, this would be false, we skip it. 4 and 5, this is true, we print it out. Type in 4 and 5, you'll see first value, and of course 4 and 4 is still equal. A couple of things that we should watch out for. If we put in something like equal to, less than or equal to, greater than equal to, now these aren't mutually exclusive, right? So it's possible for certain values of x and y to fall into multiple one of these categories. In fact, if I type in 4 and 4 now, I see the values are equal, the first value was larger, and the second value was larger. And that's because 4 and 4 would pass this test, that would be true. 4 and 4 would pass this test, that would be true. And the same thing over here. So that's not to say you never use greater than or equal to in an if statement, but in this particular case, it wouldn't be a smart thing to do. Another thing that we should remember, and I think I just kind of messed that up actually. Another thing we should remember is that these can be in any order. They're independent of each other. So if I take these and move them up, it doesn't really affect anything about the program because, again, if I get rid of these equal signs, each one of these is mutually exclusive. So it doesn't matter whether we check if x is greater than y before we check if x is equal to y. Only one of them are going to actually be true at any given time. So from the user's perspective, it makes really no difference in the world which order you check these things. That's not always going to be the case. As we start to learn more about conditional execution, we might see some situations where it would depend largely on the order in which we check on things. So as we learn if statements, there's a few things that that are fairly common errors when you're using this new syntax. And I want to go over 3 representative samples of potential errors. And what's very particular about these type of errors is that they aren't syntax problems. The compiler will not tell you that there's anything wrong with these if statements, and rather than kind of go through them on the slides, I'm going to run each one of them and show you what's happening. So let's move over to Visual Studio again. And I've written the first one all the way on the left as a program. So let's run this, and if we look at it, you know, we initialize to x equals 6, and then we're looking to see whether x equals 5. Certainly we would expect nothing to print out because x is not equal to 5. If I run the program though, we can see line 1 prints out. So for some reason this statement over here ends up being true, which doesn't seem to make a whole lot of sense. So this is kind of best understood if we remember what's happening with all of our operators. So I've put the code over here, and let's just draw out our variable x. So when we're on this line of code, we create this value, and x is equal to 6. Right? So the next line of code does an if x equals to 5, but the big problem here is that we've got this equal sign, the assignment operator. So we've written x equals 5 instead of x double equals 5. Right? And that's going to give us our major issue. Right? So when we say x equals 5, what we really do is we change the value of our variable. Right? We're assigning 5 into x, and that's a critical difference. Now, if we have an if statement, we expect a Boolean expression to be in there. Right? And when that if statement comes in, my pen's not really working too well, sorry about that. That if statement is going to expect that Boolean value. And when it sees this x equals 5, it's going to evaluate the expression. Right? And 5 gets assigned into x, and as we know, the assignment operator yields whatever value got assigned into that variable. So we've got 5. If 5 will result in true. Anything other than 0 when cast to a Boolean value will be true. Right, so that statement becomes true and we print out line 1. Right, and that's why we're seeing that confusion. Okay, so we see what's wrong with this first one on the left. It's that assignment operator. And notice, because C++ understands the assignment operator, it doesn't consider it a compiler error, and so it's an easy bug to have creep into your program. You want to be very vigilant, just like integer division, about not getting caught up in one of those statements. There really is, unlike integer division where sometimes it's useful, there really is no situation where using an assignment operator instead of a double equal sign is a good idea inside of an if statement. So it's something that should almost always be avoided, and in fact in other languages has been made to be a compiler error. On the right hand side here I've got the second example, x equals 5, and I'm comparing it correctly, as you see. But we've got some more issues or potential issues with it. So if I bring over Visual Studio, I've got the same code. If I build it and run it, we get line 1, line 2. Right, so that should be expected, right? So x is equal to 5, we're comparing x to be equal to 5, and we get our 2 lines of code. If I change this to 6, we should expect nothing, right? The if statement is false. If I run it, however, that's not what I get. I get line 2. So this line was skipped. This line was actually still run. And the problem here is that we've forgotten the braces. So when we write an if statement without any braces, one line is attached to the if statement by default. The fact that this second cout statement happened to be nicely indented and lined up with the other print statement, it gives us the visual indication that it's connected to the if statement, but it doesn't tell the compiler that it is. So essentially it's the same as just writing something like this, where we've got an if statement and then a statement that executes regardless of that Boolean expression. Now, whether that was what we wanted to do or not, the compiler really doesn't know. The compiler doesn't know that that indentation necessarily means that we meant to connect it to the if statement. It's the braces that do, of course. So now if I add those braces, both statements, all statements within the braces are tied to that if condition. And if I run this, I won't get anything to print out. So that's an important lesson in that it is in general a good idea to just get into the habit of always putting these, even though the compiler will allow you to skip them if you only want one statement to be associated with it. Now moving on to the third one, it's a little bit less common, but I have seen it. I've seen some problems, or some students of mine use this syntax occasionally and become confused as to why things aren't working. Let's move over to Visual Studio and run this one as well. So I've got my code up. Let's build that. And notice we do get a warning on this, and it's always a good idea to think about warning. It says empty control statement found. Is this the intent? And let's keep that in the back of our mind when we see what prints out. So when we run it, we get line 1 prints out. Now x is equal to 7. If x not equal to 5, that's of course going to be true. That's a true statement, and we see this print out. And if we're not really thinking carefully and we're not testing carefully, we might be sort of lulled to sleep here, and we might just say, okay, well, it works, right? I saw line 1 print out when x was not equal to 5, so there's no problem with my program. The issue here, though, is if x happened to be equal to 5, and I run this, I still get line 1 to print out, and that obviously is probably wrong. The issue here is that the if statement is directly followed by a semicolon, and we're used to putting semicolons. I'll actually see this more if you use the style of having these braces start and end on their own lines, which some people like to do. This semicolon ends up winding up here more often than I notice by mistake. The if statement followed by a semicolon basically is just saying if x is not equal to 5, do nothing. Right? The semicolon is just an empty statement, equivalent to cout end of line or cout something else, whatever that might be. We know that that statement would be attached to the if statement or the if condition. The presence of just a semicolon is actually a real statement in C++, but it's really not doing anything. After that comes these braces, but these braces are actually allowed anywhere. We don't need to have an if statement at all. We can put an open and closed brace and surround some statements in it if we want. It doesn't affect the execution of the code at all. When we run this, we'll of course just get line 1. Those statements are totally disconnected to my if statement, which is just saying if x not equal to 5, do nothing. And of course it's the equivalent of doing something like this. All right, this is one single statement. These are optional in this case, but we could have written them as well. Now that's probably not the intent of the author, right? So if we look back at the original syntax, it looks something like this. It seems clear, it seems obvious that you probably wanted line 1 to print out only if x is not equal to 5, but of course the compiler doesn't know that. The compiler is interpreting it differently. That's probably the least common mistake I see, but just kind of a stray semicolon, but every once in a while it does give some people some problems. So a great thing about if statements is that it starts to allow us to do a better job in making sure that we're working with correct data. And so, something like a situation where the user is asked to type in a radius, we can now write an if statement to check to see whether that radius is less than 0. And if the radius is less than 0, we can print out a nice message. We can say, sorry, a circle must have a radius larger than 0. If the radius is greater or equal to 0, we could go ahead and write the rest of our program. And so that's a very convenient feature of using if statements. And what I want to do is, you might want to try that on your own, but let's look at a little bit more complicated example where we use the polynomial equation, or the equation to solve for the roots of a polynomial equation or a quadratic formula. In this type of a problem, the user or the reason we would use this formula is we've got an equation of the form ax squared plus bx plus c, where a, b, and c are coefficients. And when we have a polynomial like that, we can find or we can solve for the roots, and the roots just simply mean what x values would make that formula be 0. We can solve for the roots by looking at these two formulas. There's possibly two roots. So the first one is negative b plus the square root of b squared minus 4ac, all divided by 2 over a, or 2 times a. And the second root would just be with a minus sign between the b and the square root. So we can write a program pretty easily to do this, but what's important for us to know is that if b squared minus 4ac, what's in the square root, it happens to be negative, we're going to get really bogus results from our square root function. Square root function is not designed to work with negative numbers. So if that's the case, we would like to, instead of actually, and this is called the determinant, this part of the equation, if this happens to be negative, I want to stop. I don't want to actually proceed with the calculation and print out the roots of the equation. So let's go to our code, and what I tend to do is, rather than error check right away, I tend to write the code so I can find the right answer. In this case, really, it's just 2 calculations to compute the 2 roots to a polynomial equation, and then add the if statements later to help with the error detection. All right, so I've gone ahead and written the first small bit of this program. And so I've read in A, B, and C, and then we're just going to sort of plug in this formula. So looking back again, let's look at the first part. Let's just do the first root first. We've got negative b plus the square root of this stuff divided by 2a. So not talking about if conditions or anything like that. A simple word of advice from me would be to always, whenever given an equation like this, solve for the numerator first. Solve for the numerator first, and then create a variable to hold that numerator, and create a variable to hold the denominator, even if it's quite simple. And then just divide the numerator by denominator to get your ultimate result. That tends to avoid a lot of precedence rule issues. If you write this formula without any parentheses, you won't quite get the answer right, likely, because the precedence orders of the pluses and the division sign. So as I go through this, I'm going to actually create a variable for the numerator and a variable for the denominator. I'm also going to observe that the determinant, this part, is similar, or it's exactly the same in both cases. Right? It's always b squared minus 4ac. And since I know ahead of time that I'm going to end up using that determinant in some sort of a condition, I'm going to use a temporary variable just for that interior as well, and that way I can reuse it in both sides. So the first thing maybe I would do is create a variable b squared minus 4ac. So I'll just do b times 4 times, oops, no, not times, minus 4 times a times c. I will then create a numerator variable, and that'll be, and let's remember what that was, negative b plus the square root of the determinant. Negative b plus the square root of the determinant. And we're using the square root function, so let's, and we already have CMath, just a reminder, we need to include that. The denominator is just 2 times a. That's pretty easy. And so the first root, and we'll call it root 1, is just numerator divided by denominator. Now the second part to this, the second one, the numerator is different. The denominator is exactly the same. So in fact, I can reuse the same determinant variable. I can reuse the same denominator variable, but I'm just going to calculate a different numerator. I don't need to create a brand new variable for num. And the reason being is that just because numerator is going to change now, that won't change root 1. Root 1 is already computed. It's stored in memory. So I can say numerator is now negative b minus the square root of the determinant. And of course, that doesn't affect root 1 in any way. All right, it's just reassigning numerator. Double root 2, and again, I'm declaring the variables sort of as I go. I'm not redeclaring numerator. I don't need a new variable. Double root 2 is just numerator divided by denominator. Again, this time with a different numerator. And I can print out the roots. All right, so if I build that, go ahead and run it. I'm being asked to enter the A, B, and C, 2, 3, and 1. I come back with -1/2 and -1. Now, the first thing, before we even worry about if statements, we've been down this road before. We need to, of course, check it. And again, quadratic formula, solving for the roots of polynomial equations, it's fairly easy to find something online to get that information. So why don't we just do that and make sure that our simple test case was correct and maybe test a couple of more. So I just went into Google, I typed in quadratic equation solver, and I found a site that would do that for me. If I take our inputs, so my sample was 2, 3, and 1, type in that for A. I see -1 and -0.5, so my numbers are coming up with the same as this program. And depending on how much I trusted this particular site, I might check somewhere else, but I'm fairly confident this works. And again, this 2x squared plus 3x plus 1, that's generating this curve. The roots are for what x values does that curve pass the 0 plane. All right, so let's see what happens if our determinant b squared minus 4ac is negative. Let's see what would happen right now. And a quick and easy way to do this is type in a 0 for b and some positive value for ac, and you'll know that that's negative. So we'll run this 3, 0, 4. And we see that both of our roots are really non-numbers. That -1 dot pound IND really is anytime the computer can't numerically represent a value, that's what you're going to see print out. And the square root of a negative number is not something that the computer can represent. It's an imaginary number, and so that certainly doesn't map to binary. So what we want to do is we want to avoid that sort of embarrassing printout, and we want to just have the roots print out correctly if the determinant is positive, and if it's negative, just kind of politely say that you can't do it. So if we go back to our statements, all of this, after the determinant computation, all of this really is depending on the fact that this determinant is not negative. So we can put that in an if statement. If determinant is greater or equal to 0, all of this should happen. And we'll keep in mind our indentation. And then we can say if determinant, and by the way, in a future module, we'll of course we'll learn how to make these if statements, these mutually exclusive paths, a little bit easier using the else statement. But for now, we'll just keep it like this. If it's less than 0, we can just say, sorry, there are no roots. So we build it and give it a run. Let's test our initial test case first, make sure nothing went wrong. Yes, that's still good. We'll type in 3, 0, and 4, and now we see, sorry, there are no roots. So using an if statement, we can make, from the user's perspective, our program look a lot more a lot smarter, have nicer output for our programs. Behind the scenes, we sort of have to think of all the different pathways that we might go through, but it's some simple uses of if statements can